Hi everybody. So in this video, I'm going to show you how to find the area of a sector. So we'll work through 3 examples and then we'll try some exam style questions. And if you want to work along with me, you can download this PDF from my website. I'll leave a link below. So to begin with, I want to show you where the formula for the area of a sector comes from. We have this sector, OAB, where this arc length encloses the 2 radii. We want to find the area of this sector. Well, you can see that this is a fraction or a proportion of a full circle. And we know the area of a full circle is pi times the radius squared. But the question is, what fraction of this circle is it? Well, it's the angle theta out of the entire 360 degrees. So this is our fraction of a circle. This angle out of the entire 360. So the area of a sector will be the fraction theta over 360 multiplied by pi times radius squared. So it's the fraction of a full circle, okay? And as we progress through the video, we're going to be using this equation. So if we look at example 2, so in this example, we've been told that A or B is a sector of a circle, centre O, and we've been asked to find the area of a sector in centimetres squared to 3 significant figures. So we've got our radius and we've got our angle. So the area will be the fraction, which is theta over 60 degrees out of the entire 360 multiplied by pi times the radius 5 squared. Okay? Now it's a good idea to try and simplify this fraction whenever we can. And we can see that this fraction both will divide by the 60. So we get 1 over 6 multiplied by pi multiplied by 25. And we can write this as 25 pi over 6. And this is in centimetres squared. So quite often we're asked to leave it as a multiple of pi. And this would be the area as a multiple of pi. We could convert it to a decimal. And then we get 13.1 centimetres squared to 3 significant figures. Okay? Let's try example 3. So for example 3, we're given the sector with radius 8 centimetres and the angle 120 degrees. We need to find its area to 1 decimal place. So perhaps you want to give this question a go yourself. So the area will be the angle 120 divided by the 360 degrees multiplied by pi multiplied by the radius squared, so 8 squared. For our fraction, we can divide both by 120 to simplify it, and we get 1/3 times pi times the 64. And we can write this as 64 pi over 3, again in centimetres squared. We could convert that to a decimal, and to 1 decimal place we get 67.0 centimetres squared, okay? Let's try another question. So now we've been given this composite shape, and we've been asked to work out the area of this green shaded region, given the answer to 1 decimal place. So again, do you want to give this question a go yourself? You can pause the video, and when you come back, we'll go through the solution. Okay, so how did you get on with that? If we look at our strategy, we're going to work out the area of the big sector, and then from this, we'll subtract the area of this smaller blue sector, and this will give us the green region. So we know the radius of this will be the 6 over 5 to give us 11, and we know the angle will be 40 degrees. So the area will be the 40 over 360 multiplied by pi multiplied by the 11 squared, 121. And we can simplify the 40 over 360 as 1/9. So this will be 121 pi over 9. And that will be the area of a bigger sector. If we look at the smaller sector, this time we'll have a radius of 6 and the same angle of 40. We know the area. As a fraction, we can simplify to make 1/9. It'll be the same as this one. So 1/9 times pi times the 6 squared, so 36. So this will give us 36 pi over 9, or 4 pi. So the shaded region will be the 121 pi over 9 minus the 4 pi. We can work this out and we get 85 pi over 9. And as a decimal, this is 29.7 centimeters squared to 1 decimal place. Okay? How did you get on with that? Let's try another question. So in this example, we're told that the regular pentagon of side length 5 centimeters has each vertex at the center of a sector of radius 2 centimeters. So the radius is 2 centimeters and the length of a pentagon is 5 centimeters. We need to calculate the total area of all the sectors, so the total of each of these added together. So again, do you want to give this question a go? You can pause the video and come back when you're ready. Okay, so how did you get on with that? Well, the first thing we need to do is to work out the angle of each sector. And we know for a pentagon, we can work out the exterior angle, which is this angle here. This is the same for each of our angles of a pentagon. You can see that all of these angles rotate around a circle. So one of them will be the 360, the full circle, divided by 5. We can divide it by 5 because they're all equal. So the exterior angle of a pentagon will be 72 degrees. And if this is 72, we know this will be 180. So the angle of our sector will be the 180 plus the 72. And this gives us 252. So if we just look at one of the sectors, we know the angle is 252. We're told that the radius is 2 centimeters. So the area will be 252 divided by 360 multiplied by pi multiplied by the radius squared. We can work all of this out on our calculators and we get 14 pi over 5. In the question, we were asked for the total area, and you can see there's 5 of these sectors. So the total area will be the 14 pi over 5 multiplied by 5. These 5s will cancel, so we'll get 14 pi centimeters squared. Okay? How did you get on with that question? Let's try one final question. Okay, so for question 6, we've been asked to work out the area of this yellow region. And we've been told that angles A, B, and C are shared in the ratio of 4 to 9 to 5. And the sector has a length of 5 centimeters. So do you want to give this question a go? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So the first thing we need to do is, again, we need to work out this angle. Now we know that angles in a triangle add up to 180. So we need to divide this 180 by the total number of shares. And this is 18, the 4 add the 9 and the 5. So each share will be worth 10 degrees. And if this has 4 shares, this will be worth 40 degrees. We know this is a right angle, which means C must be 50. So now we can work out the area of the sector. We'll work out the area of a triangle, and then we'll do the triangle take away the sector. That will give us this region. So to find the area of a sector, we know the angle is 50 degrees and the radius is 5 centimeters. So the area will be the 50 over 360 multiplied by pi and the radius squared. So we can simplify this fraction. We'll divide both by 10. Then we'll have 5 times 25. So we'll have 125 pi over 36. And then we need to work out the area of a triangle. We know the base is 12, perpendicular height is 5, and the area of a triangle is 1/2 of a base times the height. So this will be 1/2 of the 12 times the 5, and 6 times 5 will give us 30. So the shaded area will be the area of a triangle, 30 centimeters squared, minus the area of a sector, 125 pi over 36 centimeters squared. And I want to show you how we can enter this into our calculators. So all we do is we enter 30 minus, then the fraction button, 125 pi, this is shift and 7, divided by 36. And we get 19.09 centimeters squared. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.